So now we'll be moving on to another section in this course, which will be called logical operators and basic functions. So we've already worked with some basic functions. We're going to add it, teach you guys a few more, but logical operators you can think of as kind of true or false statements. So let's start off with an example that I think will better exemplify what I'm talking about. So let's say I have 10 greater than 8, okay? So obviously, I'm sure you guys know that 10 is greater than 8. But we can use certain logical operators. These are going to be things such as equal signs, greater than, less than symbols, greater than or equal to symbols, and they're going to produce true or false statements for us, which will be quite helpful when we develop more of our programming and analytical skills. So let's just run the line 10 greater than 8. And when we run that line, we see that we get a true statement. So that's very obvious, but it's important basic concept to understand how we work with greater than or equal, greater than or less than symbols, and that they produce these true or false statements. And I'm going to start off with, give you another example. Let's try 8 greater than 10. Obviously, 8 is not greater than 10, so we should get a false statement. So if we run line 64, indeed, we do get a false statement. So those are some basic examples, but let's build on that by writing some more complicated logical statements. So let's try, let's find the sum of grades. In order to find sum, we can use there's actually a function called sum. So we type out sum, and then if I want to find the sum of grades, so that's that original vector that we created that's constituted by 5 separate elements. And if we want to find out if the sum of grades is greater than the sum of new grades. So new grades is when we added, I believe, 5 percentage points to all of the original grades. So this should be false. The sum of grades should actually be less than the sum of new grades. So let's see if we get a false statement. And indeed, we do get a false statement. So if we want to find out if the sum of a certain vector is greater than or less than the sum of another vector, we can use these logical operators, these less than or greater than symbols, in order to find those answers. So let's try another example. We'll also add another basic function. We're going to use the mean function. So if we want to find the average value of a vector, so we're going to type mean, and then we're going to put our object grades within the function. And we want to find out if the mean of the vector called grades is less than the sum of the vector called new grades. So when we run that line of code, we get a true. So those are just some basic examples of how we can use logical operators to find if certain statements are true or false within RStudio. But it's also important to note that true and false statements are actually associated with ones and zeros. And this can get a little bit more complicated, but is an important concept when you develop more of your analytical skills. So I'll just write another section of my code that says true and false are associated with 1 and 0. That might sound kind of confusing, but I'll give you a couple examples that will demonstrate what I'm talking about. So let's say I'm going to create a statement, an object called statement1, and I'm going to set it equal to the mean of grades less than the sum of new grades. So we actually ran this logical statement earlier. The mean of grades indeed is less than the sum of new grades. So you're probably thinking, okay, this is going to produce a true statement, which it will. But what I'm trying to demonstrate to you is a true in R is also understood as the value 1. So let's say I run that line, and All right, so now I'm going to actually add a true statement to a true statement. So we should actually get the number 2, which may seem kind of confusing, but if I add this statement 1, which is true, because the mean of grades indeed is less than the sum of new grades, and I add it to itself. So if I have statement 1 plus statement 1, and I run that line of code, we actually get a value of 2. So that just demonstrates to you how true statements in R are actually understood as values of, as ones, and false statements are understood as the value 0. And now let's work with a false statement. We'll create a statement 2, and then we will set it equal to the sum of grades greater than the sum of new grades. So I think we ran that earlier. The sum of grades is not greater than the sum of new grades. So we should get a false statement. And indeed, we see in our environment, we get a false statement. But now let's try doing some arithmetic with true and false statements. So if I have statement 2, and then I add it to statement 2, I should get a 0. And indeed, we do get a 0. So if we actually can do arithmetic with true and false statements, which is kind of convenient. Let's do one more example. If I have statement 1, and then I add it to statement 2, so a true statement plus a false statement, hopefully I get a 1, because 1 plus 0 is 1. And indeed, we get a 1. So I just wanted to give you that little tutorial demonstrating how true and false statements are actually associated with 1s and 0s in RStudio. And now I'll create a new section into my code, which is going to be entitled More Logical Statements. So I'll just give you a couple more examples of how we can use some other symbols when we're working with logical statements. So let's try the logical statement if 10 is equal to 8. So an important concept in the R programming language and its syntax is that when if you want to use a logical statement to determine if something is true or false, and you want to use an equal sign, you actually have to put 2 equal signs together. So you can't have, if I wanted to find out if 10 is equal to 8, and if I run that line, we get an error because R thinks that you're setting the value 8 to equal 10 as if you're creating a new object. So let's say I created an object called 10 and then I set it equal to 8. You can see that in our environment, the object 10 is equal to 8, but that's not what I'm trying to do. I'm trying to determine if I'm trying to use a logical statement, a logical operator, to create a true or false statement. So if I want to do that, I need to use a double equal sign. So I'm going to use 10 double equal sign equal to 8, and hopefully I get a false. Indeed, we do get a false. That's what I was trying to demonstrate to you guys. Let's try another one. Let's use a greater than or equals, greater than or equal to symbol. So if we want to use greater than or equal to, we start with the greater than, and then we use the equal sign afterwards. So is 10 greater than or equal to 8? Hopefully we get a true statement there. Indeed, that does produce a true. And then we'll use one more example of a less than or equal to symbol. So less than equal to 10 is less than or equal to 8. Hopefully we get a false statement. And indeed, we get a false statement. So just a couple more examples of working with logical statements. So if you want to find if something is equal to something else in a true or false context, you have to use the double equal sign. And now we'll create another section that will be entitled More Basic Functions. So we've already worked with a sum and mean, but now let's try to work with square roots. So how do we find the square root of a given object? Well, we can start off by creating an object that's called square.root val, square root value, and we'll set it equal to So let's say we're trying to find the square root of that original object called the grades. So we're going to use the square root function. That function is designated by sqrt. And then we're going to open up our parentheses, and then we're going to type in grades. And hopefully this will be able to find the square root of grades. And if we type out that value, square root val, and click enter, we find that R was able to actually didn't find the square root of all of the grades summed together. It found the square root of each unique element within grades. But let's say I wanted to find the square root of the summed value of grades. So I can do that by, well, we'll create an object first called square of sum. And we'll set it equal to the square root of the sum of grades. So an important concept when you're working in R with multiple different functions is that you work in, out. So first we're going to find the sum of grades, and that's within the interior of the parentheses, and then we move out to the exterior, and then we're going to find the square root of that summed value. So first, we're going to find the sum of grades. In fact, I can just actually highlight this little object here and run that. So we're trying to find the square root of 371. So if I run that line, and then we can type out square of sum, we see that the square root of 371 is 19.26. So I just wanted to demonstrate to you guys to show you that when you can use multiple different functions within one line of code in R, but R will always work in, out. So if you want to find the square root of a summed value, first you start with the sum, and then you put the square root symbol on the exterior.